In this video, we are going to see about Arima, which stands for AutoRegressive Integrated Moving Average. It is one of the statistical model used in time series forecasting, which means predicting future value based on past values of the same variable. For example, we need to predict tomorrow's temperature, which will be based on today's temperature. That is on your past value predicting tomorrow's temperature. Again, when I talk about Arima, I'll give you another example is value of your number today is influenced by three main things. For example, what happened yesterday and before that, how much have things been changing, how wrong were my past predictions. So these are the things the Arima model says. We'll see in detail how this Arima model calculates and how this predictions been done. So before going to in-depth of Arima model, it is a statistical tool used in time series. Already we know about what is time series. Is a simple data recorded over time, either a daily closing price of a stock or monthly sales figure. When we are analyzing this data, it is often broken down into three parts, or we can say four components. That is the components I have shown in the graph here. One is trend, a long-term movement or a general direction of the data. Simple example, if I want to say, sales are generally increasing year after year due to population growth, or if there is any there are any dips every December, upward direction is there. So this upward direction is said to be trend. The next component is seasonality, that is predictable, repeating pattern, or that happens over a fixed time or a short period of time, usually less than a year, like a day, week, or month. That we can say this pattern are ties to the calendar. A simple example is ice cream sales are always much higher every summer, lower every winter. This yearly cycle is seasonality. Sometimes you'll hear about cyclic, that I'll let you know what is cyclic. Cyclic refers to recurring ups and down in a time series that is not a fixed period, typically last longer than 1 year. But when we say seasonality, it holds less than a year. It depends upon a week, month, and it is always pattern is tied to the calendar. But cyclic is not like that. It will be more than a year. For example, it is not fixed. It is not tied to the calendar. One cycle might last for 3 years, next might last for 8 years. Like this goes on. So longer duration, if you see, the cyclic typically span multiple years, often 2 to 10 years or more. So they are usually driven by broad underlying economic or business forces, or you can say business cycle. We have seen the life cycle of a business like recession, recovery, boom. So it depends upon this, and the cyclic period goes on. So their length is unpredictable. Cycles are often mathematically difficult to model and are frequently grouped with trend component and becoming trend cycle. To say difference between a cyclic and seasonality, cyclic is not fixed or it is not predictable, but with seasonality it is fixed and known, it is predictable, and usually that will be less than 1 year. It will be longer than 1 year. So less than 1 year, it may be a daily, monthly, yearly, but you can't predict like that in cycle. Usually the cyclic will cause under a business condition or recession, like that cyclic component will occur. Whereas if you take seasonality, depends upon holidays, depends upon weather condition, climatic factors, everything it will occur. And in cyclic, if you want to say good example is going through multiple stock market going through a multiple year down and rebound. That is, it may be increase or decrease likewise. So this is what cyclic. And the last component is irregular. Irregular is leftover, random, or unpredictable, I can say. That is unexpected. One time sales will be spike because a major competitor went out of the business, um, and or a sudden or unexplained drop due to bad weather. It is a random noise in the data. When you add or multiply these components together, they make up the complete observed time series data. So breaking time series down into these parts helps understand the data better and make more accurate forecast. So one such forecasting is Arima. And these Arima model is again been have three main concept in Arima. We'll see one by one. First one is auto-regressive. For example, the value today, that is prediction of its is own past value. That is, if today one value is there, it is a prediction of from the previous value. For example, if your running speed was fast yesterday and the day before, it is likely to be fast again today due to momentum. So this auto-regressive parameter letter is denoted by P, tells the model how many past data of data to look for this momentum effect. And the second one is I, integrated trend remover, we can say. To make good prediction, we need the data to be flat and stable without a big constant upward or downward trend. Now you got the meaning for trend. We have seen trend that is an upward direction. The data constantly rising like stock price, the model will struggle. So to fix it, the model using differencing. It does not model the actual value, but the change in the value. For example, that stock price is 10 rupees, to 12 rupees, 11 rupees and 12 rupees. The model will change it as 1, 1 because the difference is 1. It is rising 10, 11, 12. The rising value, it will take it. So the parameter here, it will be denoted by T. It tells the model how many times it needs to calculate this change and get rid of the trend and make the data stable. So in order to calculate Arima, the value must not be trend, that is upward downward movement must not be there. It must be constant and stable value to calculate. That is what the second component. Now the third component is moving average. The value today is influenced by the error, that is a mistake made in the past prediction. If you consistently underestimated your daily sales last week, that means your model has a bias. So this moving average part uses those part error to correct and improve today's forecast. So it will be denoted by parameter Q, tells the model how many past prediction error to include in the correction. So again, I'll clearly explain these parameters in the forthcoming slide in deeper so that you can understand clearly. Stationarity matters. So when we talk about this, a time series is stationary. That is, if it core statistical property like mean, variance, that is variance, you know how spread out of data is, do not change over time. So what is mean by stationary and non-stationary means? We'll first talk about non-stationary. If the temperature starts low and keep climbing higher and higher every year, when you say keep climbing higher and higher every year, it denotes clearly that is a trend component. The mean temperature is always changing. This is non-stationary. Stationary means if the average temperature always hover around 25 degrees centigrade and the range of fluctuation around 25 degrees centigrade always stays the same. If always stays the same, it is stationary. So when we calculate about Arima, why it is needed here means always when you calculate, the model must be stable and flat. So it must be stationary. So there must not be any fluctuations like the data must not be related to trend. Like every year it is increasing or decreasing. That must not be there. So this stationary means you need to have the data flat and stable. That is fluctuation must not be there. If your data has a constant trend, that is non-stationary. The model can easily predict the next step because the rules are always shifting. If your data is stationary, the model can confidently say, I know the long-term average, the typical fluctuation. So my prediction will be based on those stated rules. So this is what stationary. When we again will see what are the parameters we have used in these components. Here you can see auto-regressive P and integrated D moving average Q. Again, I'll let you know how it been used in this model. Auto-regressive means the model uses the relationship between an observed and number of lagged observation to predict the features. What is meant by that lagged means, for example, when you say yesterday and the day before stock price, so that difference is said to be lagged. Past observations, the number of past observation is said to be lagged. So lagged observation is the value of time series at previous time step. When you say yesterday and day before yesterday, that observation is said to be lagged. Here the parameter P is the order of AR, that is auto-regressive part, which is the number of past observation to be included in the model. So auto-regressive P means, for example, if you say P equal to 2, it uses two values, that is yesterday and day before yesterday. For example, stock price. Yesterday and day before yesterday's stock price will help you to predict today's stock price. That is what auto-regressive. Integrated. Integrated refers to the use of differencing. In previous slide, I was discussing about stationary. That is one whose statistical property like mean variance do not change over time. When it is do not change over time means it is stationary. It changes means that is like a stock price or sales have trends or seasonality, then making them as non-stationary. So differencing means subtracting the previous observation from the current observation. This helps to remove the trend. That is, it will help to remove the increasing or decreasing value. So it will keep us stable. And you might have to do this more than once, because when you have too many past observations, you need to do more than once. So here parameter D for integration is used, is the order of differencing, which is the number of times the raw data has been differenced to achieve stationarity. So this is what integrated. Last one is moving average. When you talk about moving average, the model uses dependency between an observed and residual error from a moving average model applied to lagged observation. I'll let you know what is residual error, the difference between what the model predicts and what the actual value was at the past time. So that is what residual error. So here the parameter Q is used in order of a moving average, which is the number of lagged forecast error to be included in the model. Lagged forecast error means you very well know what is meant by lag. That is subtracting how many previous observations you have. That is what's said to be lag. The difference is the difference between the predicted and the actual value is said to be residual error. If the model was constantly under predicting sales last week, incorporating those past error helps the model adjust and make better prediction for this week, for this week's sales. So this is what Arima comps. And here example I have given Arima 1, 1, 1 means the p value is 1, that is you are taking only one past observation. Another one, d value is 1, that is the lag value, the difference it takes and 1. For example, the stock price is 10, 11, 12 for 3 years. The difference 10 to 11 is 1. So that 1 alone, the difference data once alone it is taken. Moving average again it is 1. So this is what it denotes how many past error influence the prediction. So I am taking one past error. So this is an example for Arima. If this is given, automatically it shows the prediction for the current. And here a simple example for forecasting shampoo sales been given here. When a shampoo sales is given for over 3 years, what you will do first one? First you need to check for stationarity. That is today's shampoo sales is 10, tomorrow's is 12, means it is keep on increasing. That is trend is there. So you need to check for stationarity. Either it is a constant is there, or trend is there, or seasonality is there. The time series components we need to check and apply the differencing here. Then we need to identify parameters. As we know, the 3 components of Arima is there. So we need to identify all these 3 parameters, P, Q, and you can fit the model and generate the forecast. So this is what Arima model.